Okay, now we are going to connect to a switch and actually make some configuration changes. The last time we did connect to a switch and we showed the running configuration, but we didn't actually manage any of the switch's settings. So we're going to do that today. Now I'm going to show this in Packet Tracer. It's going to be a little bit different using an actual Windows or Linux computer. Because everything here is simulated, it's a little bit easier in Packet Tracer, but I can at least show you the principles. Now, every Cisco switch and router, they are going to come with a console port. A console port is used to make the configurations. It looks like these Ethernet ports you can see on the switches, but instead of being on the front of the switch, these are on the back of the switch. Even though we don't see the console port here, this switch, I promise you, does have a console port. This is what a console cable looks like. It's got these 9-pin connectors on this side and something that looks like an Ethernet jack on the other side. Older laptops might have this kind of connection. Modern laptops typically don't. You might need a USB adapter to actually connect to a switch. If we look at the lab guide, here's a picture of an older series Cisco 2960 switch. You can see the console port highlighted. It basically looks like the other ports on the switch, the Ethernet ports, just slightly different. It's special. That's where we're going to plug in our console cable. Now, if you're connecting using a Linux laptop, you are going to use a command called a program called Minicom. So you'll connect the cables. You'll connect the console cable into the switch. You'll connect the other end into the docking station of your Linux laptop. You'll open up a terminal and you'll run these two commands. Sudo su, so again, that gives you root privileges. And then you're going to run minicom /dev/tty capital S 0. Now in this, capitalization is very important. Typically in the Windows world, capitalization doesn't matter. You can type commands uppercase, lowercase, you can mix the case up, it doesn't matter. In the Linux world, uppercase and lowercase matter. So you have to type this in exactly. So you have to type in minicom space /dev/tty capital S 0. So this /dev folder in Linux refers to your devices. So you might have a USB device, a network interface card device. You might have a sound card device, a bunch of different devices that correspond to your hardware. So your serial cable connection is a device. So when you're running this command, you're saying, okay, program called minicom, I want you to connect to the serial cable device to connect to the Cisco switch. So you run that command, and all of a sudden, you're making configuration changes on the switch. In the Windows world, it's a little bit different. We've got adapters. You can get this USB adapter so that you can plug in the USB side into your laptop and then plug the console cable into the adapter and then into the switch. When you install this USB adapter, 90% of the time the adapter installs automatically. If it doesn't, there's a link to download the driver. You can download the Windows 7 driver even if you're using Windows 10. Now, once you connect to this adapter, the funny thing is Windows puts it on a different COM port every time. If you open up your Windows Device Manager in the control panel, you can expand ports, COM, and LPT after plugging in that adapter, and you can take note of what COM port that adapter has been installed to. For example, in this screenshot, this adapter has been installed to COM3. That's just what we need to remember. COM3. Next, we're going to download and install PuTTY. We launch PuTTY. PuTTY knows how to speak to Cisco switches and routers. So we open that up, open up PuTTY, the program, and we create a new connection. So here, I've created a new serial connection using COM3, and I'm calling it Cisco. So when I open that up, it will connect me to the switch. Now, if you're using a Mac, good luck. Students have told me that these instructions work. I don't have a Mac to test them on. It is possible to connect to switches and routers using a Mac computer. It's just not something that I have done before, so I'm going to skip over these instructions. Now, those previous instructions that I just kind of blew over, I blew over them just because I can't really demonstrate it using a virtual machine. I can't really demonstrate that process in Packet Tracer. I can demonstrate the process for resetting a switch's configuration. So here, I'm going to add, I've added a switch. I'm going to add a computer to my workspace. Then I'm going to click on these connections, and I'm going to click this console cable. I'm going to connect it to the PC to this RS-232 port. That's just your serial cable. I'm going to click on the switch. It asks me where I want to plug it in. I'm going to choose console. So now my PC is physically connected to the switch. That's good. So I'm going to click on this PC and come to the desktop. Now, instead of in Windows, you would launch PuTTY, but here I'm going to launch Terminal, this terminal program. I click that. All these defaults are fine. I don't have to change anything. I click OK, and all of a sudden I am connected to this switch. It says press return to get started. So okay, I will follow instructions. I will press return to get started. And I can see that switch prompt. So this should look somewhat familiar. From using Packet Tracer, we looked at the switch configuration using this prompt previously. I'll show you another way to get there in Packet Tracer. In Packet Tracer, I can just click on the switch, come to the CLI tab, and I've got that prompt right there. You can see that the output is being mirrored. Now, just in Packet Tracer, clicking on this switch and going to the CLI tab is almost cheating. It's almost like we're giving ourselves godlike visibility into the configuration of every device. In the real world, in the physical world, we always have to be connected by cables. So if you are configuring a physical switch, you will have to plug in this cable, and you will have to make the configuration changes from this PC. So from here, from this PC, I can make all the changes that I need to. So let's take a look at the changes that we are going to make. So here we are at the switch prompt. Now just note that if you are booting up a switch in a lab somewhere, the prompt might look a little bit different. Somebody else might have changed the name. Somebody else might have been changing basically all of the configuration changes. We need to reset those to make sure that we get rid of any crazy configurations that anybody else has made. So we're always going to begin a lot of these labs by erasing the previous configuration. So let's go through how we can do that. If you see S2, S1, S3, S anything, it doesn't matter if it's different. We are going to change that anyway. Again, the command that we need to use is enable. Hit enter, and we can see that now we see switch pound. That shows that we've gone from user exec mode into privileged exec mode. Now you may be prompted for passwords here. The only two passwords excuse me. The only two passwords you should ever use on these physical switches and routers are lowercase class and lowercase Cisco. Don't use any other passwords. So if you ever use another one of your classmates' switches and they added a password, it should be Cisco or class. I'm going to scroll down, look at the instructions. The next command that we are going to run is show flash. Okay, when I run the command show flash, there's really nothing there. Nothing much very interesting. Showing flash, that command just lists the configuration files on your switch. Because I'm using Packet Tracer, my switch was basically just created for me virtually, so there's nothing much on it. On your physical switch, there might be leftover configuration files from another student's project, something that somebody was working on. So you might see other files here. Really, the file that we're looking here is one called VLAN.dat. VLAN stands for Virtual Local Area Network. It's a configuration file. If it exists, you have to delete it. So I would say delete VLAN.dat. So here's a gotcha. Cisco will prompt me to confirm delete file name and then in brackets VLAN.dat question mark. You will be tempted to answer the question potentially and write out yes or hit Y and hit enter. That will not work. When Cisco prompts you like this to delete VLAN.dat, you just hit enter again and confirm just by hitting enter. So it tells me there was no file called VLAN.dat, no such file or directory. That's okay, no harm done. Everything is good. So for this switch, I am now going to run the command erase startup-config. Here's a hint. If I type erase and I type st tab, if you hit the tab key, Cisco will fill in the command. If there's only one command that it could possibly be, it'll write it out for you. So use the tab completion to avoid typos when you can. So erase startup config, I'm going to hit enter. It tells me erasing the NVRAM, that's non-volatile RAM, that's the stuff that gets saved even when you turn the device off. Erasing the NVRAM file system will remove all configuration files! Exclamation point. Continue, question. Enter to confirm. Again, don't type yes, don't type Y. Everything's good. So it erased it. Now we are going to reload the switch. Proceed with reload. Enter to confirm. If you are prompted to save the system configuration at this point, just type no and hit enter. Again, because we're trying to erase everything. So this booted up fast. If you're using the physical routers and switches, it can take 2 to 3 minutes for these switches to reboot. And you'll see a bunch of weird characters on the screen. Don't worry, everything's fine. If you think your switch has just gone crazy and you're not sure if it's crashed, you can always just hit enter. Hitting the enter key, if you're not typing a command, will never do the switch or router any harm. I'm going to hit enter here. It brings me to the prompt. Just keep pounding the enter key, it doesn't matter. All right, now, many times after you reload the switch, you will be prompted with the following message. Would you like to enter the initial configuration dialog? Yes or no? So there is a yes or no question. You always want to type no. You don't want to do that. You might think, well, yeah, it's time for class to start. I'm going to start configuring it. Sure, let's start configuring. You're going to type yes. You don't want to do that. Just hit no. If you happen to get into the initial configuration dialog and you start answering questions and it doesn't seem right and the instructions don't tell you to do any of that stuff, Control-C will jump you out of that. Okay, now that our switch has been reset, it's time to actually go in and make some useful configuration changes. So I've got my PC open, I've got my terminal open, I'm going to hit return to get started. So all of us now, after resetting the switch, we should see the same prompt, switch greater than. If you see something different, your switch settings were not reset correctly, you need to go through that process again. But I'm going to use the shortcut enable command, EN, hit enter, and then go into config mode and use the shortcut again, conf T. That's short for configure terminal. Now I'm going to change the host name to my last name. Host name Markwardson. Hit enter, and you'll see that the prompt changes again. So now it says Markwardson, and then in parentheses config. So it means the name of my switch is Markwardson, and I'm in config mode. It's useful to change the host names of these switches to help keep track of what we're working on. If you have a very large network in an organization, you can have hundreds and hundreds of switches. And if you just name them switch 1, 2, 3, 4, 5, or if you don't even give them a descriptive name, it's going to be really hard to keep track of everything. So I've named mine Markwardson. Now I'm going to give this switch a banner so that anytime someone logs into this switch, they're greeted with this banner. Banner MOTD. MOTD is message of the day. And then whatever I put between the pound symbols, that's what my message is. So I'm just going to say access restricted. If you were a company, you could say this switch belongs to Acme Corporation. Unauthorized access will be prosecuted to the full extent of the law, whatever you want to say to warn people away. Some people say that if you don't put a banner message warning people about access, that you can't prosecute. It's kind of like saying no trespassing. It's just a best practice. Everybody puts it there. Just go ahead and do it. All right. And then, just like in the Linux world, no news is good news. We ran the command, but it didn't tell us, didn't give us any errors, so I guess that's good, right? Now we are going to configure that console port that we're using to access this switch. So to access that one port, I'm going to say line con 0. This is how we access that console port. And I'm going to run a few commands. You can see now we see config-line. So every command I'm running now is going to configure that specific interface. So I'm going to say password Cisco. So that if someone tries to connect through that console port, they have to enter the password Cisco. Now for that to work, I have to issue the login command. And if you notice, I just updated a typo here. It's okay, things happen. So I'm going to run login. The next command that I'm going to issue is logging synchronous. I don't want to type out synchronous, so I'm going to type sy tab, fills it in for me. That's helpful. Hit enter. Now, why do I need logging synchronous? Well, Cisco on its hardware likes to give you very helpful status updates about what's happening on your switch or router. So many updates can happen, though, that they might update you while you're typing a command, and it will actually interrupt what you're typing, and you'll lose track of what's going on. Using logging synchronous, that will prevent Cisco from honestly just being too annoying. So that's good. I'm happy with the way my console port is configured. I'm going to exit. Now people can potentially connect to these switches and remotely and make configuration changes. So anytime somebody types enable, let's say we want to prompt them for a different password. So it's another layer of security. So I'm going to run this command in config mode, enable secret class. No news is good news. All that's good. So now we've password protected the enable command. So I'm going to exit, and I'm just going to close out this terminal for now. Let's say hypothetically, I come here to my computer. If you're on Windows, you're going to use PuTTY. Here I'm going to use my terminal. Click OK. And now it says access restricted. So that's the banner message that we implemented. It also says user access verification. So I can't even see the switch prompt. I'm kind of locked out of my switch at this point. So what password do I need to enter here? Think about it. Pause the video if you need to think about it. Well, we configured 2 passwords, right? We configured the enable password. We also configured the console password. I am trying to connect to the switch to the console port. So that is what the switch is going to prompt me for first. So for the console port, we use the password Cisco. So I'm going to type that in. C-I-S-C-O, enter. Okay, so now I'm into the switch, into user exec mode, but I cannot make any configuration changes yet. So I am going to run enable, and it's asking me for another password, right? Remember, the command that we ran was enable secret class. This basically says whenever somebody runs the enable command, they have to enter class. So class is the password that we're going to enter. Now, C-L-A-S-S, and we are in. We are into our switch. Somebody who didn't know my passwords would not be able to make any configuration changes to this switch without kind of hot wiring the hardware. So our protection has increased dramatically. So we've made a bunch of changes to the switch. It's running just the way we want it to for now. But how do we save that configuration? Well, to save it, we use the command copy, run, start. Copy, run, start. It says destination file name, startup-config, question mark. So you just want to press enter again. Don't type yes. Don't want to do that. Hit enter. It built the configuration. Okay, so now if I reboot this switch, oh, I shouldn't have typed reboot. I should have typed reload. I made a mistake. Here's the thing. Sometimes on a Cisco switch, if you type an invalid command, Cisco thinks that you're trying to reach, or in this example, the reboot domain. Like I'm trying to go to reboot.com. And so it's going to look it up forever. I'm going to pause the video. Okay, I'll pause the video for 20 seconds while this command timed out. I'll leave this in there. Everyone makes mistakes. It happens. Which command should I have run? Can you correct me? Yes, it is reload. That's what I should have done. Confirm, so it's going to reboot. So what's going to happen when it reboots? Am I going to be back in privileged exec mode? Try to make a prediction. What do you think is going to happen? Press return to get started. Okay, user access verification. So if we remember back what we did, we use Cisco and class. Now we're back in privileged exec mode. So everything is saved. So So we've essentially secured this switch so that unauthorized people can't just come in and make any configuration change that they want. So you should be able to now connect to a switch using Minicom on Linux or PuTTY on Windows. You must know how to reset the switch configuration. This should be muscle memory. Just to connect your computer to the switch and reset the settings, reload it, it should take 4 minutes tops once you get practice. Some people, they're typing away for 15-20 minutes. You need to get that process down. So practice in Packet Tracer if you need to. We've protected the console port. We've protected the enable command. We set a banner message. We changed the host name. We changed our logging. We saved our configuration file. And now I included instructions in here on copying text from PuTTY. I'm not using PuTTY right now, so I'm not going to demonstrate that. For your submission, I want you to issue the show run command and just copy and paste all of that output into a text file. Everything from current configuration down to the end. Copy it in a text file, upload that. Now when you're finished, as part of the cleanup, I want you to erase the switch configuration. So how do I do that? So I'm going to run show flash. I have no VLAN.dat file there, so I don't need to delete a file that isn't there. But I am going to erase, start, and I'm going to hit tab, erase startup config. Do I want to do it? Yep, I want to blow it away. Enter, reload. So that time, I did the appropriate command. So this is going to reboot. Now in class, you don't have to wait for things to reboot. You can yank out that cable while your switch is rebooting. That's fine. It's not going to interrupt the boot up process. Hit return to get started so I can see I was not prompted for a password. The host name has been erased. This switch is basically fresh from the factory clean. And everything is good to go.